Hello YouTube viewers, welcome to my channel S2T. In today's show, Rocket Monday, we're gonna talk about Raccoon, aka rocket balloon. So let's dive right into it. Well, before we understand why the heck this strange contraption rocket and balloon exists, we have to understand what is our primary problem. So our primary problem is atmosphere. Now, why does that matter to us a lot? Well, think of this way. Atmosphere does not give a damn if you are going slowly. Basically, if you are bicycling, atmosphere does not care. But as you increase your speed, the amount of atmospheric issues goes up drastically. So if you are traveling at, let's say, 500 kilometer per hour, atmosphere has some serious control over how much energy you need. Let's say you are talking about 2000, like a fighter jet. Yeah, atmosphere is like, bro, like you have to pay a penalty for that. So think of it this way, like if a fighter jet is that's only going 2000 kilometer per hour compared to a rocket that has to go as high as like 28,000 kilometer per hour. So you can understand that like atmospheric drag becomes a significant drain on the energy reserves. Then we also come to the another aspect. The energy that you are extracting in a rocket is generally coming from a nozzle. You have a rocket engine, then you have the nozzle. Now nozzle also suffers a side effect of that, simply because you have to have a nozzle which does not deals with what we call gas separation. Basically, if you have a nozzle, you have a nozzle like this, gas is coming out, it must follow the nozzle. Otherwise if it separates from it, the wall separation happens, it will start oscillating, it will start shaking your rocket engine, and in most scenario it ends up rocket engine blowing up. So it's not attainable. So what we have to do is basically design something that matches the indoor and the outdoor pressure, aka your basically exhaust pressure must match the ambient pressure. And that is why you can easily see in fighter jet they have a nozzle that adjusts itself. Now in rockets you cannot do that. Again, you can do that, it's just too much, way too much expensive. So what we come up with is like basically we have two stages in rocket. So one stage, basically the first stage, the booster rocket ends up getting sea level engine. What does that mean? The engine is the same, only difference is they are using what we call the nozzle is specifically designed for sea level. So the easiest way to visualize it, think of it this way. Falcon 9 has a cylindrical design. Now the cylindrical diameter is exactly the same. It's not like a Saturn 5 where diameter changes. It's the exact same diameter in first stage and second stage. Okay, everything is awesome with that. But here's the stage 1 booster has 9 engine, while the upper stage only has 1 engine, because the nozzle is so damn huge. So that's the reality of it. Like this is the actual size contrast that you have to understand. So nozzle also becomes a issue. Now it's not an issue if you are only flying in the atmosphere, but the moment you start your basically rocket, it starts to go up. So this nozzle effectiveness goes down before it even exits the atmosphere. So this becomes another drain on your system. Then we come to the most difficult aspect, max q. So what does happen is basically your rocket is accelerating. Now as it's accelerating, it's consuming fuel, it's getting lighter. So even if the engine throttle is exactly the same, your acceleration will increase simply because you're getting lighter and lighter and lighter and lighter. So they reach a point where you are moving so fast that atmosphere is not thin enough yet that it starts acting as a shockwave. Even though you are going directly up, it's still creating a shockwave above it because you are traveling so damn fast. So people generally throttle down the engine. It's like, oh, okay bro, chill down. And it has to be done, otherwise rocket will suffer severe damage. ICBMs are designed so they can punch through it, but normal liquid fuel rockets are not, they're not fan of it. And every time you throttle down your engine, you lose efficiency. Yeah, it sounds counterintuitive. It's like, max throttle is the best case scenario for rocket engines, but max throttle cannot be extended because max q will destroy your rocket. So these are the three core problems of it. So what is the idea? Now, idea is an old idea. Like it's not something like some magically came up with some session or all that. The idea was very simple. Atmosphere is our issue. How we bypass it. So the project Farsight was created in 1957, and this is the first practical project they are talking about. Like many people have attempted this before. It's like this project was successful. It was so successful. The dude who orchestrated all of this got the Val Anner radiation belt named after himself. Now he figured this out, that radiation belt is using the balloon project itself. So the idea was they're going to use high altitude balloon. Now this is one crucial aspect. You're not talking about hot air balloon. Hot air balloon does not go very high up. You're talking about high altitude. So generally either using helium or hydrogen, you're going to go very high up, as high as 30 to 40 kilometers up. And then you're going to fire solid rocket motors, because liquid, you do not want to slosh around when you are going up. And not to mention, if it's cryogenic, it will evaporate before you reach your launch altitude. Solid rocket was chosen, and it's simple, it's much more resilient to shocks and all that. So Four-stage rocket was chosen, and it is basically a sounding rocket that turbocharged it, and it went through the balloon. Basically, once it reached the launching altitude, they went directly through the balloon. It's like, and it was so fast because again, there is not atmosphere fighting against you. It went so fast the balloon did not even collapse before the rocket left it. So that was done. Now it was designed for a ballistic trajectory, aka go high up and fall. It was not designed for orbital system, so it does not have the speed necessary for orbit, and they did not even want to. They wanted to achieve the basically altitude. So they achieved the altitude of 64,000 kilometer. Let that sink in. That's almost exceeding the lower basically low earth orbit. Like low earth orbit is classified as like at least 5,000 kilometer. Even this puppy exceeded that. Our international space station is below that, so it's very fast, very far, and done for fraction of the cost. So this idea was really put on steroids, and they wanted to pursue launch systems where they can throw things at moon. So this was a really successful tested idea. So what is the hope with this? Like, why the heck people are going back to it? Well, high altitude balloons are cheap because even in simplest scenario, if you are talking something very expensive, you are barely talking $400 for store bought system versus $4 or $5,000 compared to a few $1 million rocket. So it is super cheap, and you have to use hydrogen for maximum efficiency. Why not helium? Again, helium does not have lifting capacity, so hydrogen is the best case. And you are talking about safety, you are talking about rockets, they detonate, so hydrogen is safe enough. So, and the main benefit of that, even though carbon line is specifically drawn at 100 kilometer, below it, it's not like atmosphere goes to zero. It's like 100, you are 99 kilometer, 100% atmosphere, it drops a zero once you cross it. It's like very concentrated in the sea level. Basically, sea level is the maximum atmospheric pressure. The moment you cross like even 10 kilometer, the pressure drops drastically. It's not a linear relationship. Most of it's below you. So high altitude balloons reaches a point where it's like 99% of the atmosphere is below you. Like even planes will have hard time breathing in this kind of scenario. So even fighter jets do not fly this high up. So that's the reality of it. Now the nozzle, the benefit of the nozzle will become is like you don't have to design a sea level nozzle. You have to only design one nozzle, a vacuum optimized, and it will give you the maximum performance. And then because you are literally outside of the atmosphere, there is no drag. While you are increasing speed, there is no drag. And because if you are traveling even 1 or 2 kilometers, you are literally in vacuum of space, so there is no shock wave. You don't have to worry about max Q. Now why does that affect a rocket design? Well, fairings are a multi-million-dollar aspects of a rocket system. Like many people asked Elon Musk in Twitter, it's like, why the heck you are trying to recover the fairing? It's like, yeah, it's just a $5 million piece that I have to recover. So that's the reality of it, and they have to be designed so they're overbuilt. Basically, they're literally glorified cover, but they have to be overbuilt so they can handle the max Q, vibrations, shocks, all that jazz. They have to handle that. Now if you are just floating up there and then firing the rocket, and when the atmosphere is not fighting against you, the fairings will become just a small thing. And you can easily see this in the movie Martian, when they're removing everything, because the idea was very simple. If by the time you are traveling fast enough for air drag to matter, you will be high enough that there will not be enough atmosphere. So it's the same thing that we want to achieve. Okay, so all the hopes is good and all that, and it has actual backing. We have actually achieved it. So what's the reality of it? Reality is you need two components for actual orbit. For a satellite, you need two components. The two components are height and speed. You cannot just go high up. Like that does not send you in orbit. That just gives you a ballistic trajectory, which is generally preferred for ICBMs, but not for satellites. So you have to cross 100 kilometers. The reason for that is generally we defined it as such that that is the carbon line. On top of that, it's guaranteed at that point that if you have a satellite, it can orbit at least for 2-3 days bare minimum. And in the early days, that was the requirement, simply because the batteries did not lasted long enough and solar panels took some time to figure out. So 100-kilometer altitude is like bare minimum for making sure that there is not enough drag that your satellite will burn up or literally fall out of sky in minutes. So minimum 100 kilometer, and then you have to have the speed, and that is because these two components are independent of each other. You will see rocket launches that are going like completely straight, So why the heck they make that 90-degree turn? That 90-degree turn is built for that exact reason, because once they are outside of atmosphere, height does not benefit them. They need speed. So once they are outside it, rather than burning propellant going up, increasing their 100 km/h, they were like, okay, make sure we get that 28,000 km/h for second stage at least. So that's the reality of it. Though balloons can go high, they can go higher than any commercial aircraft, but they are still limited to 35 kilometers, 40 if you are pushing it, and they detonate once they go so up. Is that is why they are never full to the full pressure, because the idea is once they start to go up, the atmospheric pressure will drop outside, so it will expand. So this allows them to have room to expand, so it does not burst into nothing every few thousand feet. So they allow it to go to very high atmosphere, but that's how it comes down. It's like once it reaches the booms. So if you really can't expect it to go higher than like 40, best case scenario. So 35 is the reality of it. Now on top of that, the carrying capacity of this puppy is not in hundreds of tons. It's not like a jumbo jet. It does not have tons of capacity. Barely it has 500 kilo, 600 kilo, few tons maximum. And like for even to achieve few tons, the balloon size becomes like a stadium. Like the balloon will be literally the size of a stadium. So the carrying capacity is not huge, and the practical reality of it is like it's only suited for small sounding rockets. Do not expect to hey, I'll tag around Falcon 9 or even Falcon 1 on it. It cannot be done simply. And you also have to understand liquid fuels are flat out simply because again you will be having a rocket that is sloshing around for like hours. Cryogenics will simply evaporate, and non-cryogenic does not have enough oomph, so might as well use solid booster, which are reliable enough in this scenario. So that's the reality of it. It's only suited for small things. So what we can expect in the future? One simple thing you have to understand: the CubeSat market, it has exploded. It's like every Tom, Dick and Harry is making CubeSat. Heck, it's a school project nowadays, not even university or not even college. It's like a school project. People want to build it that cheaply. Can it be done? Yes, our electronics industry is powerful enough. However, the launching industry is not that cheap. So that is why there is a new market. Like if you want to cheap satellite launch, ideally you want to launch hundreds of them. Same way India has the world record of multiple CubeSat launched in one go, which was 100 plus CubeSat launched in one go. So okay, but here's the problem with that: you may not have 100 CubeSat. On top of that, you also have to worry about your it's basically like I'm only gonna launch the train once it's completely full. So you cannot be like I'm gonna call ISRO and I'm gonna like, hey, I want to launch satellite. They're like, yeah, we have next week, we're gonna give you that. No, it's really like, yeah, okay, we put you in the schedule, then another company, the once it will fill up, then they will launch it. So that is why there is a new market which is much more expensive per kilogram, but it's much more quicker. So like Rocket Labs and their Electron rocket is specifically tailor made for this. It's like you want to launch a cube satellite, but you want to launch it now, and you want to be like, yeah, the solar flare is happening, I want to capture it. So they're like, yeah, I got you. They will bring up your system. Everything will be done in months rather than years. So there is a very huge demand for CubeSat that you can launch right now. Basically, I'm gonna call up, I'm gonna give you the delivery of the satellite, just launch it. So a lot of people will pay premium for that feature. Ballute allows us to achieve that. Again, it will still need redesigned rockets. It will need dual stage system. It's not gonna be a single stage, and it can be done. We have done it in the past. It can be done. It's just that instead of ballistic trajectory, we have to go into orbital trajectory, and it can be achieved simply because CubeSats are mostly aimed for low Earth orbit. So it can be done, and we're gonna see a lot of Raccoon launches recently, simply because many people have already started sending balloons up and firing rocket reliably. So stage one is already complete. Then some people are trying to target some other aspects of that. They want to make space tourism. Now again, technically it's not space tourism because you're not breaking through the Karman line and you are only at 30, best case scenario 40 kilometers up. But the benefit is that is so high up that sky is black. Now this is how you know whether you are in the atmosphere or outside it. The moment you go outside, the daytime will become black. That does not happen in aircraft. Like commercial aircrafts generally are at a high altitude. Even a fighter jet that goes very high up, you can still see light blue. Yeah, it's not absolutely thick blue, but it's light blue. But when you're talking about like high altitude balloons, that's black. Like if you look out the window, yeah, it's black. So they are aiming for that. It's like and it will be expensive. They are targeting at $100,000, below $100,000. Now like that's too expensive. Yeah, but compared to a rocket launch, that's free. So that's the reality of it. They want to exploit that aspect. Is like, yeah, you're gonna see quote unquote space, and technically it's space because most of the atmosphere is below you. So there are a lot of people who want to exploit this ballute phenomena. Let's see how it turns out in the future. So this was my presentation on Raccoon, If you like they really have to work on the name. If you like it, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I'd urge you to press dislike, press it twice to show me your actual disappointment, and please leave a comment because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.